Hello everyone, welcome back. So in the last video or in the previous day, I made a video on reservation. Okay, that's another topic. So we'll continue our series on motion. And in today's class, this is the very last topic. This is the last topic of this chapter, that is circular motion. Circular motion is the last topic of this chapter because after that, there will be no classes of it, just one practice session. If I think a practice session actually exists, then I will take the practice session as well. But right now, you are going to see the concept of the uniform circular motion. Okay, so let us just know what is. See, I told you that I will actually discuss the types of motion today. So, the types of motion. Now there are how many types of motions are there? First is rectilinear motion. Okay. Another is oscillatory motion. Okay. Third is oscillatory motion and periodic motion. And fourth is rotatory motion. Fifth is our topic circular motion. Okay. So first is rectilinear motion. So in the rectilinear motion, there is the displacement of a particle in the same line of the motion. As for an example, if a bus is moving on a straight road, then all the particles, or say all the persons sitting in them, are moving in just one direction. So rectilinear motion means straight line motion. Okay, and another motion is curvilinear motion. Okay, rectilinear and curvilinear are part of any other motion, but yes, rectilinear is most important one, straight line motion. Oscillatory is to and fro movement of anything, like pendulum clock. Oscillatory motion. Periodic motion and oscillatory motion both are different. Periodic motion actually repeats after an equal interval of time. Okay, so periodic motion can also be said as to and fro motion, but that motion, to and fro motion, but at equal intervals. हर equal intervals में जितना motion होता है, that is called periodic motion. There is a difference. Don't see that oscillatory motion को मैंने ये भी बोल दिया. For example, एक झूला होता है ना, we just tie that two ropes in two point places and we just push one of the the swing. Then its swing does not repeat at after an equal interval of time. It is not like that. But in case of periodic motion, there is a repetition. So actually, the pendulum clock movement is not actually the complete example of oscillatory motion, because that oscillatory motion just suggests to and fro. That doesn't suggest that it in an equal interval of time, but it repeats after an equal interval of time. Roughly, it is an example of oscillatory motion. Now, your work is to find out at least 5 or 6 examples of all these types of motion. This is how the physics is studied. Study it from anywhere, but remember, whenever there are types of anything, types of force, actually it's your work to find out at least 5 or 6 examples. I'm not telling you the examples more, but because if I'll tell you the example, you will not be able to think. You will just learn it. So that is why. Rotatory motion is too easy. There is a difference between rotatory and periodic. Rotatory means rotating at a fixed axis. It has a fixed axis, like a top. So a top actually rotates on a fixed axis. Now, if this is a duster, and on this, if it is put here, it should rotate on its axis. Suppose this is its axis, this. So if it rotates, it is rotating on an axis. So that is an example of rotatory motion. Periodic motion, I explained. Accelerating motion, there is a difference between those. Rotatory motion, rotation. Okay? Rotation of Earth. Rotation of Earth is also an example of rotatory motion. There are a lot more examples of types of motion. I have just mentioned some of the few to just give you the feel of all the types of motion. Now your work is to find out at least 2 or 3 rotatory motion. And now the topic is circular motion. So I gave you a brief introduction of all kinds of motion. This is rotatory motion. Okay. Rotatory of a motion, that means along a fixed axis. Okay. And another kind of motion is I think related to R also. It also starts with R. Your work is to find out that kind of motion. And actually there is a difference. Okay, so you have to find it out. Okay, let us just start circular motion. Very easy topic. No need of worrying about whether you will understand or not. It's very easy, very easy. And I told you in the previous video that I will be teaching you angular acceleration, angular velocity, but I will not be teaching that, because that will become, that will take 2 or 3 classes at least. There should be a knowledge about the radian and degree, how to convert radian into degree. So that will take time. Okay, we just need to know the basics here. No need to for just. This is what? This is a circle. What is a circle? A circle is a locus of point from, this is its radius. A circle is a locus of points or a collection of points such that the distance of one point from the center remains the constant. For anything, for any particle, the center distance remains constant. So that is, this is also R, this is also R. Okay. So this is a basic property of circle you should know. Okay, and one more, the basic thing you should know about circle is that if you see the direction of circle, वो हर moment पे change होता है. That changes it at every moment. At every moment it changes. Like for example, if you take direction here, it will change like this. If you take here, it will be changed like this. It will be changed like this, and like this. In this way, the direction changes at every interval. So this motion is known as accelerated motion. First, what is circular motion? Okay, what is circular motion? Circular motion is motion along a circular path. Okay, motion along a circular path, and it is also known as accelerated motion. Known as accelerated motion. Why accelerated motion? Because we know that acceleration is a vector quantity, and you know that if a vector quantity, it is a vector quantity, then it will have magnitude as well as direction. So if direction is changing continuously, definitely velocity will change, and if velocity is changing, definitely acceleration will be there. And at each moment, acceleration, it's just that at each moment velocity changes and acceleration acts. That is why this kind of motion is called accelerated motion. इसको accelerated motion इसलिए बोलते हैं क्योंकि जो हमारा acceleration है, that is a vector quantity, and if a vector quantity is there, it has direction as well. So at each interval, velocity is also vector quantity. So at each interval, if you will see, that will change its direction. It's changing its direction. So if direction is changing, definitely acceleration is there because velocity is a vector quantity. Okay. Now there are two types of. Let me draw a small circle. Okay, a small circle, very small circle. There are two types of circular motion. First is uniform circular motion, next is non-uniform circular motion. So this is the circle, this is the radius r. Now just uniform circular motion, UCM. Don't be confused about what is UCM. UCM is uniform circular motion and this is non-uniform circular motion. Okay, so here in uniform circular motion, the speed is constant, speed doesn't change. At each interval वेलोसिटी की सिर्फ डायरेक्शन बदलती है, उसका मैग्नीट्यूड सेम रहता है. दैट मीन्स टू से अगर सिर्फ मैग्नीट्यूड अगर हम वेलोसिटी का देखें तो सेम रहता है. दैट मीन्स स्पीड जो होता है वो हमेशा सेम होता है यार. यूनिफॉर्म मोशन का तो मतलब यही होता है, स्पीड दैट इज इक्वल डिस्टेंस इन इक्वल इंटरवल ऑफ टाइम. सो स्पीड यहाँ पे क्या होगा, हमारा कांस्टेंट होता है यूनिफॉर्म सर्कुलर मोशन. नेक्स्ट velocity is variable. Why variable? Because it changes its direction. Okay, motion is accelerated, obviously this is the motion is accelerated. Okay, now here in non-uniform motion the speed is not constant, isn't constant. Okay, and here velocity is variable. Velocity is also variable and motion is always accelerated, right? So this is a difference between uniform circular motion and non-uniform circular motion, very easy. Now there comes the main part, and there comes the main part of this. I'm running this out. So the main part of this topic is, I will tell you one thing, that whenever something moves, it actually is acceleration. हमें पता है this motion is acceleration, and if you have studied about that force is equal to ma, right? Am I right? Yes. This m is constant for a body. Mass is constant, either on Mars, either on Earth, either on Venus. Everywhere the mass remains constant. The only thing changes is weight. Weight is due to acceleration due to gravity. That is another topic. But mass is constant for a given body. So we replace mass, and there is a rule of physics that whenever you replace a constant, you will apply a proportionality sign. This is a rule. And whenever you replace a proportionality, you just add a constant. So I am removing a constant here, so I will add a proportionality sign. So force is directly proportional to acceleration. That means to say that whenever there is an acceleration, there is a force. That there is no situation where acceleration is there, no force is there. Everywhere wherever there is an acceleration, there is a force, right? So one thing is that this is an acceleration, but what is the value of acceleration? इस acceleration की value होती है v square per r. वेलोसिटी जिस बॉडी की होती है, मतलब स्पीड जो होता है हमारा, उसका स्क्वायर डिवाइडेड बाय द रेडियस. अब ये कहाँ से आता है, फिर इसके लिए वेक्टर्स पढ़ना पड़ता है हमें. अभी हमको इसे नहीं जानना है, वी जस्ट नीड टू ऐड. बस हम लोगों ने ये मान रखा है, अभी के लिए याद रखना है कि v स्क्वायर अपॉन r. देखो डेरिवेशन बताने में मुझे कोई दिक्कत नहीं है, बट वेक्टर यहाँ पर जो है रूल अप्लाई होता है, दैट इज वाई. ओके, तो यहाँ से a इज इक्वल टू v स्क्वायर बाई r होता है. अब हमें पता होता है दैट फोर्स, डेरिवेशन कर रहा हूँ मैं, एक फोर्स आता है, और इसी फोर्स को हम क्या कहते हैं, इस एक्सेलरेशन की वजह से एक फोर्स लगता है टुवर्ड्स द सेंटर एक फोर्स लगता है जिसको हम बोलते हैं सेंट्रीपिटल फोर्स, FC. सो दिस इज सेंट्रीपिटल फोर्स. ठीक है, सेंट्रीपिटल फोर्स. ये एक स्यूडो फोर्स है. स्यूडो फोर्स देखो, दो तरीके के फोर्सेस होते हैं, एक रियल, एक होता है स्यूडो. रियल फोर्सेस, the fundamental forces in nature, four fundamental forces in nature, that is electromagnetic force or electrostatic force, electromagnetic force, gravitational force, strong nuclear force, weak nuclear force. These are four types of fundamental forces. So these are called real forces, and centripetal, centrifugal, contact, non-contact, non-contact or contact, they are also included in real forces. But centripetal, centrifugal, Coriolis force, these all are the examples of pseudo force. Jhutha, pseudo means jhutha. We just actually assume that this is a force. एंड अब हमें पता है कि ये फोर्स का फॉर्मूला आप कैसे लिखते हैं. देखो ये एक्सेलरेशन हो गया, तो फोर्स क्या होता है, मास इनटू एक्सेलरेशन. ये इक्वेशन 1 मान लो इसको. इक्वेशन 1 की वैल्यू एक्सेलरेशन से कितनी आती है, और यहां से ही तैयार हो जाता है हमारा सेंट्रीपिटल फोर्स. F इज इक्वल टू m इंटू वी स्क्वायर बाई आर. सो दिस इज द फॉर्मूला. यहां से आता है ये फॉर्मूला हमारे पास. F is equal to mv square by r for the body movement in circle. और इस एक्सप्रेशन को किसने दिया था, एक साइंटिस्ट थे जिनका नाम था ह्यूजेंस. ह्यूजेंस का नाम याद रखिएगा. ह्यूजेंस ने वेव थ्योरी के बारे में बहुत अच्छी उन्होंने अपने पोस्टुलेट्स भी दिए थे. ह्यूजेंस गिव द फॉर्मूला ऑफ सेंट्रीपिटल फोर्स. नाउ अब हमें एक चीज पता है, बैलेंस फोर्स और अनबैलेंस फोर्स. बैलेंस फोर्स अनबैलेंस फोर्स अगले चैप्टर में है, ठीक है. अभी क्या होता है ना, कोई भी अगर बॉडी इज इन मोशन देन इट इज इन इक्विलिब्रियम. फोर्सेस जो होते हैं कैंसिल कर रहे हैं दूसरे को. तो अगर एक बॉडी घूम रहा होता है, चक्कर काट रहा होता है, देन देयर इज अ फोर्स एक्टिंग ऑन दैट बॉडी, दैट इज mv स्क्वायर बाय r, सेंट्रीपिटल फोर्स. बट आउटवर्ड भी तो एक फोर्स लग रहा होगा, तभी तो बॉडी घूम रही, नहीं तो बॉडी तो स्टॉप हो जाता. ओके, सो दिस इज हाइजेंस ने इस फॉर्मूले को दिया. और फिर हमने माना कि भाई अगर एक फोर्स अंदर की तरफ है तो एक फोर्स इसको कैंसिल करने के लिए, इस फोर्स को इफेक्ट को कैंसिल करने के लिए एक और फोर्स बाहर की तरफ लगा होगा, जिसको हम बोल रहे होंगे सेंट्रीफ्यूगल फोर्स. सेंट्रीफ्यूगल फोर्स. सेंट्रीफ्यूगल फोर्स का जो मैग्नीट्यूड होगा किसके इक्वल होगा, सेंट्रीपिटल फोर्स के इक्वल. मतलब इसका एक फॉर्मूला है mv स्क्वायर बाय r. So this is a very simple, topic, circular motion. Okay, you just need to find a lot more examples on different types of motion, rectilinear, curvilinear. These are some kinds of motion in which you have to practice. Not practice, you have to find the examples. You see a lot of motions around you, right? I can actually show you different types of motion. Okay, so we have done with this topic. This was the last topic of our chapter. If hopefully I get some questions on that topic, we'll practice tomorrow. Okay, and if I get questions on that topic, I will give you the questions on these topics tomorrow, the DPQs. Okay, now we have done with this chapter. Almost this chapter is done. If I get the questions tomorrow, I will do it. But the question is that we will be going to start chemistry. The very first chapter of chemistry, matter in our surrounding. Many people say that start atoms and molecules, but I will start with matter in our surrounding because it's a very basic topic. It's gonna help you in entire class 9th and 10th. That's why I'm just particles movement obviously will help you in class 9th and 10th. That is why I'm teaching that chapter. Force and laws of motion. Keep revising on these videos, and force and laws of motion will be coming after the completion of matter in our surrounding, and matter in our surrounding will be taught in very much detail as I taught you the motion, because I taught you a lot more extra things also. Okay, so we have done with this chapter. Tomorrow if I get questions again, I will give you some questions tomorrow. Okay, till then, goodbye.